to ask Jose to play the video from Erica, please.
Okay.
Thank you very much, Jose.
Okay, so I'm going to play the video of paper number 47.
Jose, I think the online, will you mind share your screen, please? Yes, thank you very much.
Ready? Thank you.
My research is about a model-driven method for crack detection in robotic inspection. Actually, the situation of the inspection is not sustainable. There is a lack of objectivity by the inspector. They have to work in a very dangerous working condition. And also there are severe disruption to the infrastructure during this inspection. So new methods for automatic inspection are needed, as the one that was developed in the San Giorgio Bridge in Genoa. That is the first time in Italy that a robotic for inspection was designed and built on a bridge, on a new bridge. There are also other methods for robotic visual inspection, as drones, with robots, legged robots, and usual camera. In particular, and also the robotic inspection, as the drone in particular, are useful for building a 3D model for an ASIS structure. I worked in particular on computer vision method for defect detection, in particular cracks in civil structure. And this was in particular, this device was developed by the Robospect project. It's an European project whose aim is to develop the machine that can detect the cracks in tunnel. The main aim of this machine is to detect crack in image that was captured by this machine. The detection of this kind of defects is still challenging in computer vision, mainly because the structure is difficult to detect, is very sensitive to noise and also to illumination condition during the inspection. For this, the computer vision module also have to be robust with respect to these aspects. The first step, it was to develop a convolutional neural network. Here you can see the details that was used to build this network. But unfortunately, this data-driven approach, as all, is not. It wasn't successful in detecting this structure, because actually the network detected as a defect also area in the background that not belong to the defect in particular, as you can see in these images. For this reason, I decided to approach this problem from a model-driven view and using a mathematical model. The cracks can be modeled as a geometrical structure with the one dimension that is lower than the other, when the other structure, where the other dimension actually, and the challenge is related to this particular structure. So you can see in this slide is there are very sparsely distributed in the image. Their thickness is comparable to the image resolution. They have a complex geometry, and also they can be easily corrupted by noise. First model that can be used for detecting this kind of shape is the Mumford model. It's a well-known model in computer vision. It is very successful in detecting edges in object edges in the image. The problem is that and also to provide a restoration of the image, a reconstruction, a properly reconstruction of the image, so the noising. Actually, we cannot use other techniques such as a total variation, because this technique, even though are very efficient from the mathematical point of view, they corrupted the edges, so cannot be used. The Mumford could be a solution, but unfortunately, the problem is that it's a first order functional, and is not suitable for detecting cracks, because actually the crack in images are a discontinuity not in the intensity function, but instead on in gradient. So we have to come up with a second order function as the Black-Zimmermann one. And this is the one I considered, but unfortunately this mathematical object is not easily to approach from the mathematical point of view, because it's not convex, so we cannot use the usual technique that are being used conventionally in the convex optimization. We have to come up with a different technique, and we have to use, in order to solve this functional, we have to introduce a different kind of approximation, this gamma convergence, and thanks to that we are able to provide a solution. In order to build a software that can be used to practically detect these defects during an inspection, we have to come up with a numerical implementation. For this reason, we used this matricial form of the previous formula, and that is allow to use an alternative minimization technique in order to bind the three solutions that we are looking for. This technique has been tested on several HPC high performance computing cluster, but also we decided to work on a solution based on task processing, because we wanted our software to be able to be executed also on hardware architecture with power constraint, and also on commodity hardware board. And for this reason, we used the OpenMP task processing feature. We get some details about the implementation, but actually I want to go to the results. Here you can see the results. The first one is related to on a data set that was provided during the project. It's a picture taken in tunnel in Greece. And the other one is also in order to show that this technique is also able to segment the structure, even though the background is as a complicated texture. It's a sample from a concrete that was developed in a laboratory. Here you can see how the algorithm scales properly on the core. We tested on a different architecture with several different core. You can see that the scaling is as we expected. So the results are promising. This proof of concept is promising too. We would like, as a future work, to test it on new kind, as I said, on hardware architecture that have a power constraint in order to be used in real scenario inspection. Thank you for your attention. Bye.
Thank you very much, Jose, for. Oh, okay, great. Thank you very much, Jose, for playing the video. So since Erica is not online and also not in person, I assume that in this case it's hard to have a Q&A section because if we have any question, maybe you guys can read the paper and then send email to Erica to ask her directly. Otherwise, there is a video that's going to be played, which from yesterday. So please feel free to have a coffee break, or watch the video before the next section. Jose, are you going to play the video from yesterday?
Yeah, okay.
Okay. Yes, so thank you very much for attending this section. I hope you enjoyed it, and please feel free to join to watch the video or have a coffee break. The next session will start at past. Thank you very much. I wish you guys have a nice day. Jose, are you playing the video?
Yeah, I'm looking for the video and I'm going to play it.
Okay, no problem then.